Okay, let's go. So this one has to do with kind of perfect squares. And even like the quiz today, when it's in a question, it is hard to see those perfect squares. If I gave you the question, everyone, oh yeah, perfect. It's a perfect square question. Okay, so you have to be kind of getting. You got to start getting used to looking. Am I done? Could I go farther? Is there something in this question that I could still do? If you're asking that question, you're probably going to keep going with it. If you're not asking that question, you're probably going to stop. So I actually just want to go right to example 1. Now, this one to me is an obvious, and I think to you is an obvious difference of squares. But what if this was on step 4 of a question? Maybe you wouldn't see it, right? So it is kind of good just to practice these and then just see them even in a question. Now, to be difference of squares, these must both be perfect squares, and there has to be a minus sign. That's where the word difference comes from. Difference is like sum is addition, product is multiplication, quotient is division, difference is subtraction. So then all you have to do is you take the square root of 9x squared, which is 3x. You can write it in both sets of brackets. Okay, so that's what happens to the 9x squared. It becomes 3x times 3x. And if you did your FOIL, that should make sense. Then we have 16y squared, what would break down into 4y and 4y. And then what's the standard of what my signs would be? Plus minus or minus plus, right? Okay, B. Would B work? Maybe. That's really getting out there. Is there, if you cube rooted it, but 3 doesn't have a perfect cube. Yeah, you should probably GCF it, and then maybe something will happen. Anything I can take out? 3xy, leaving me with x squared minus 9y squared. So 3xy times x minus 3y and x plus 3y. See? We do. GCF, what's a good GCF to take out? Okay, so if I take out a 4, that would leave me with a 36 p squared q squared minus r squared. Again, if this was in a question, I think most people would just say, hey, can't go any farther. But it's 36p squared q squared. Can you take the square root of that? Yeah, r squared, obviously. So that would be 4. What would it be? 6pq minus r and 6pq plus r. So really has to it's just following what we've already done. But if people are missing the foundation, they're probably looking at this and going, okay, that's absolutely nuts. Let's keep going with examples. So I'm actually not going to read through this stuff because it actually makes it a bit more confusing. So let's do example 3. Now k to the 4 minus 1. Now, is this a difference of squares? Yes, it is. Because what times what equals k to the 4? k squared, right? So this would be k squared minus 1 and k squared plus 1. Okay, be paranoid. Am I done? No, because k squared can be... Now, again, know your rules. Don't go k squared minus 1 and k squared minus 1, because that's going to happen. And then you'll probably try to square them both. But it's always one is opposite the other, or else I'd have a middle term. Which one of these can I still factor? K squared minus 1, which would turn into k minus 1, oops, k plus 1, right? And then this k squared plus 1, there's nothing I can do with it. Okay, let's do B. Any suggestions? Take out 5. Is that the best we can do? Yeah, that'd leave me with 16 a to the 4 minus x to the 4. Okay, perfect squares there. So it'd be 5 bracket. What makes up 16a to the 4? 4a squared, okay? Minus x squared and 4a squared plus x squared. And you start getting into the, what's it called? I don't know, habit of going, that 4a squared plus x squared, nothing I can do with it. So it's always going to be at the end. But whenever there's a minus sign, I can keep going with that one if there's some nice perfect squares, okay? So I can do that one, right? This would be 2a minus x and 2a plus x. And then what's hanging out? That 4a squared plus x squared. Now the answer even looks quite intimidating, right? But a simple process getting there. It's just using, I mean, we've been doing difference of squares. It's like the 4th time we've done this within a lesson. So, okay, let's do C. I can take out a 2p. You can see how these are just so hard if you don't know how to do the GCF. What else? What would be left in brackets? P4, Q4 minus 81 T4. Okay. What's the perfect, like P4, Q4? What could that go into? What makes that up, I should say? P2, Q2 minus 9T squared, right? So this is going to get tight here. P squared, Q squared plus 9T squared. Now, some people say, you know what, I'm going to always get in the habit of putting my plus first and then just keep expanding my last one, okay? Whatever. Just understand this one we got to keep going with because it still has perfect squares in it. So that would be, it's funny because the notes in the book actually stopped there. So even the notes sometimes think, yeah, I'm all good to go. But you can still do that one. That would be PQ minus 3T, PQ plus 3T, and because I'm short on room, P squared Q squared plus 9T squared. Okay. Now, again, the book doesn't do this for example 4 and 5. But if we piggyback off of the last lesson, it is much easier to do these with substitution. Else they become quite laborious. And not just like when you're writing too much stuff out, there's a chance to put a y instead of an x just once or whatever, and it's just all bad from there. Okay? So whenever I see stuff in brackets, then I like to use the let a equal. Okay? It makes it much nicer to do. So I'm going to let a equal b minus c. So I didn't need brackets. Okay? So that would be a squared minus a squared. That's not too ugly. Okay, so that would be a squared, a minus a little a plus big A. Okay, can I go any more? No. So then we substitution. A, and I'm going to use brackets, b minus c. And this would be a plus b minus c. Final answer would just be a, what would it be? Minus b, plus c. Okay, I know if I was to give this on a test, I'd catch too many of you. I have to multiply a negative sign into the brackets. That's why substituting without brackets, bad idea. Okay, it's so bad that every question I would give on a test, I'd make sure if you substitute the brackets, you would get it wrong. And I'd make absolutely sure I would have that answer for you in the multiple choice. Okay? Because I need to actually know who knows their math, who doesn't know their math. And that is that's right from grade 7, right from you should know distributed property. You should have been working on that in junior high. So it is not unfair to be, and the plus sign doesn't really mess that up too much. That's your final answer. Okay, now B is kind of a new one for you because before they were both like 2x minus y's, or they were both x plus y's. But this one we're going to get really creative because math's all about being creative. So I'm going to let a equal 2x minus y, and I will let, let's go with b, equal x plus y. Now again, this is not in the notes because they wanted you to do it old school, and then next year you would learn how to do it with substitution, okay? Because we would do something like this again next year, and then you'd learn the substitution way. So why not teach it to you this way anyway, because it's easier, and you need to do it next year. So then it's a squared minus b squared. It's a little less intimidating right from the start. And then you've got a minus b, a plus b. And if you want to see how to do it the other way, you can just go, obviously, to the notes on the computer I gave you, and you can do it that way. Now I can't go anymore, so then all you do is substitute with brackets your a and b. Okay, so it's a little bit crazy with brackets, but you guys can handle it. Minus x plus y. And then I've got 2x minus y plus x plus y. It's kind of a feat in organization more than anything. Okay, now what's going to catch most people in that first set of brackets is they're not going to distribute the negative correctly. But make sure, like, do that if you have to. So this would be 2x minus y minus x minus y. This would be 2x minus y plus x plus y. So what's that first set of brackets going to equal? Still got people writing, so I'll just hold on here. What's in there? X minus 2y and 3x. And the book would have it written like this. 3x times x minus 2y. Okay? All I've done, a times b is the same thing as b times a, but usually the number, it's one term, will follow the two terms. Okay? Is this manageable? But believe me, it is something that you got to do in the steps. There's so many places where your math is tested. Like, do you know how to distribute the negative? Yes. Because you got 2x plus 1x. That's your 3x. And then a negative y plus y. Gone. So 0 y's. Okay? Again, if you go to the notes in the book, they're not going to show you how to do it with the substitution method. Same with this one. But you guys can handle it. Okay, so this one, both are different. So now we're going to have, let's do a let A statement. That is my x plus 5. You can let the B equal, and again, don't need brackets. Actually, I'm going to use brackets just because I'm going to substitute brackets anyway. Okay, so then it is 36 a squared minus 49 b squared. Okay. So this one, what would I factor this one, Chelsea? What would it look like? Yeah, so what would it look like? So do you see the difference of squares isn't so bad once you do that. And then you're just going to substitute with your brackets extremely carefully because there's a lot going on. So A is going to be x plus 5 minus 7 times x minus 8. Okay, then a big set. 6 times x plus 5 plus 7 x minus 8. Okay, so this would be 6x plus 30 minus 7x plus 56. Very good. The next set would be 6x plus 30 plus 7x minus 56. Okay, in the first set of brackets, I will have so I'll have a negative x plus 86 Or 86 minus x. That means the same thing, right? Everybody knows that? Okay, so don't get all freaked out because 86 minus x is the same thing as negative x plus 86. In the second set of brackets, 13x minus 26. Now this one, extremely mean. There is a GCF. One set of brackets has a GCF. Okay, so this would go to, this would be in the multiple choice right here. So this would be 13 times x minus 2 times 86 minus x. Okay, and just right here, that was a GCF. You're going to see how practice is really going to be vital on these because they are the same thing every time. Substitute, do perfect squares, sub back in, factor them all out, okay, and then add, subtract, like terms in the brackets, and then see if you can take a GCF out. So are you starting to write these steps down? Now this is where you become good at math, is where you actually can start being sequential, okay? Do this, then this, then this, and this. You come with a study sheet tomorrow that says do this, then this, then this, then this, okay? You will be able to do that tomorrow. You'll be able to look at these questions. I'm going to have these kind of questions that are on there tomorrow, okay? So I'm expecting that accountability for you, not just, yeah, I just do every question differently. This time I do it this way, this way. I mean, what should you always do first? What should you always do second? What should you always do third, okay? So we are doing 1 to 5, do all of them, but you can, like as in all the questions within, not A, C, E, G, but you can omit number 2.